Hi, Andrew. This is Jack, and this is our slides as is right now. I wanted to talk through them so that nothing surprises you Thursday night. Get some feedback from you. So here we go. First slide, show them who we are, and let you introduce yourself. I think that'll be fun. Also, Credit Aerospace. We lifted some stuff from that presentation that you had a hand in for sure. This is the list of our topics. Seems to make sense. I'll do the front end. I'm going to use my laser penner. We'll get this out of the way, the first slide, then I'll have some words. I'll talk about this. You'll see that in a minute. Two of my topics and something that you and Marlon helped me with. And then you have the meat of the rest of the way. And of course, we'll open it for Q&A sessions. These three slides I selected just to give people an idea of its growing, what the stuff is, how it's categorized out. Excuse me, I have contributed to this green area in my many experimentation and deployment of stuff in the 80s and 90s, so I'm a bad person. Anyway, then from a Smithsonian magazine, I pulled these titles out of an issue on space debris. We got the Worried Snoopy here. And also, just before I left NSDC, I talked about these menacing big stages out there. So I might give them a little story of numbers and size. Then, as you know, I'm fanatical about explaining what goes on inside the collision. Again, you and Marlon helped me. Just give them a little bit of a talk. Darren McKnight's always telling me it's like two water balloons hitting and going through each other. I couldn't find a cartoon of that actually happening. Maybe someday we can get that. And talk about, the momentum exchange being minimal, if any at all, and the hydrodynamics part so they understand. It continues to be an issue of people thinking these are billiard balls hitting, they're not. Then these next slides I figured would be you telling folks about the general dynamics of how what happens when there's a collision and a dispersal symmetrically of all these particles. The pinch point is a big topic of curiosity, so I figured I'd turn you loose on that. These density charts, we're going to end with the one that you gave me that was presented at the presidential activity, but let you talk a little bit about the density, altitude matters. Then, without getting too much into the perturbations and astrodynamics, talk about what makes what we see in LEO and GEO and what makes it happen, the perturbations. And there's two slides there. Then we've got this video handy. We could do that. It's divided into 3 steps, 3 segments. I could jump around and play that while you talk, so that's cool. But selected these drawings, these illustrations, so you could set up the discussion as to what happens after the collision and the spreading out of the debris. This, I think, is going to be a very interesting part of it. And then lastly, this is the attention step I put in the little handout I sent out, showing that altitude matters, and the Chinese sure didn't understand that perhaps, but how the USA test and the Indian test fortunately happened at a very low altitude. So it's been 4 minutes of me rambling through this, so I wanted to share with you what I've got teed up. Looks like we're going to have 15 to 20 people, and I'll get the Zoom link out later on. Really appreciate you doing this, and I hope we can get some generals in on this. But you're a gentleman, scholar, and a great space patriot for doing this. Thank you. And now I'll end